Hey Chem 30, my daughter's sick today, so I figured I'd make a video while she's napping here to do the lesson that I was going to do today. And so just a quick review from what we talked about on Friday is we talked about hydrocarbons, which are molecules that contain only hydrogen and carbon. We can break these into two groups, aliphatics and aromatics. Aliphatics are either straight or branch chain carbons, which can be broken into a few further groups, which are alkanes, alkenes, and alkynes. And if you remember from Friday, the difference between these is alkanes only have single bonds, alkenes have double bonds, and alkynes have triple bonds. The classification between single, double, and triple bond can be broken into saturated and unsaturated hydrocarbons. So saturated hydrocarbons mean that there is no possibility to create more carbon to hydrogen bonds. This occurs in alkanes. Everything is single bonded together. In unsaturated hydrocarbons, where if a bond was broken, there would be capacity to increase the carbon to hydrogen bond, we're looking at alkenes, alkynes, and aromatics, which have some sort of double or triple bond in their structure. Today, we're focusing on alkanes. Now, we already talked about this, but I want to go over it. So, alkanes are hydrocarbons with only two single bonds. They occur in a homologous series where the difference between one molecule and a next is just based off of the number of repeating units. And we talked about examples like this on Friday. The one thing we said we had to know was the general formula for an alkane, which is whatever the number of carbons is. If you double that and add 2 to that, that is the number of hydrogens you would get for the general formula for an alkane. The simplest hydrocarbon that's an alkane is methane, which is just carbon, a single carbon, bonded to 4 hydrogens. Then we talked about, because carbon has this capacity to keep increasing the number of bonds, it has a possibility for 4 bonds, so carbon can just keep bonding to itself. So I could have 1, 2, 3, 4, a large amount of carbon chains. To name those carbon chains, we need to know the prefixes. So we looked at the first 10 prefixes for hydrocarbons. So if you remember, 5 to 10 are the same prefixes. So pent, hex, hept, oct, non, dec are the same prefixes as molecular substances. But 1 to 4 are different. So we had this mnemonic device of monkeys eat peeled bananas to help us remember the prefixes. So if there's a 1 carbon chain, it's meth, 2 is eth, 3 is prop, 4 is bute, and the rest proceed like molecular prefixes. So some general nomenclature for alkanes, that's the general formula. Whatever the prefix is from this page, depending on however many carbons, that's what we take the prefix. And then we use a ANE ending because that is indicating that there are only single bonds in the structure. So this would be methane, then ethane, propane, 4 carbons is butane, 2, 4, 5 carbons is pentane. Once we talked briefly about the alkane nomenclature, we moved into the different ways that we represent organic compounds, which are molecular formulas, which just tell you what atoms are involved. The structural formula, which is what you would have created in in Chem 20 for a molecule. Condensed structural formula, where you leave out the bonds, or you reduce a homologous series into one structure. So this is saying that there are 3 CH2s, so these are the same thing. Or we have the line structural formula, which actually doesn't show any carbons or any hydrogens. At the intersection, it just shows where the carbons occur. So this is the molecule for propane, so technically there's a carbon here, here, and here. And I think this is where we ended off on Friday. So what we need to know here for terminology is, what is an isomer? So an isomer is a compound with the same molecular formula, but different structure. And the reason this is important because we have the difference between straight chain alkanes and branch chain alkanes. So straight chain alkanes are an alkane with its carbons all connected in a row. So all the carbons are connected in one single row. This is a straight chain alkane. The branch chain alkane has carbons in a row, but then there are these what we call branches attached to that main carbon chain. Now, these two structures are isomers because they have the same molecular formula of C5H12, but they would actually have different names and different functions because of their structure. They are isomers, but they would be named differently. And so you have to know what that term isomer is. And this is the reason, the difference between these, that we today are looking at how to name alkanes. The first three hydrocarbon alkanes, so methane, ethane, and propane, there is no other possible arrangement of one carbon or two carbons or three carbons. No matter what you look at it, it's still in the same arrangement. So these do not have isomers. Once you go above 4 carbons, you have the possibility for different arrangements. So if I look at this one here, this carbon is just butane, or hydrocarbon chain would just be called butane. This is an isomer of butane, but it has a different name because it's a branch chain alkane. And this would actually be called 2-methylpropane. And we're going to look at today how we actually develop this name. So functional groups we're going to look at a little bit later, which are just side groups or some sort of group that gives a molecule its properties. And today we're strictly looking at the alkane functional group. So in alkanes, we have side chains, which are called alkyl groups. So going back to looking at this example, this example of 2-methylpropane, propane is the main carbon chain. And then I have this side group, and it's a 1 carbon, so I use the prefix of meth, and I would add that YL ending to it. So, for example, if I have a 1 carbon side chain, it's a methyl. A 2 carbon side chain is an ethyl. A 3 carbon side chain would become a butyl. A 4 carbon side chain, propyl. And that would continue on. The other thing you need to know when you're going to start naming alkanes is that the main chain is the strand of longest continuous carbons. So here, 1, 2, 3, that's the longest chain of continuous carbons. But the main chain does not have to be straight. And this is a very important thing to know as we go looking into the next few examples. Before we look at alkane nomenclature, let's just briefly talk about the properties of alkanes. These shouldn't be anything too new. So alkanes are non-polar because the electrons are shared equally between the carbon and the hydrogen in that chain. Alkanes are generally gases or liquids with low boiling points because they have very weak intermolecular forces. So when we're talking about the intermolecular forces, alkanes only have London forces acting on them. They don't have dipole-dipole forces because they're nonpolar, and they don't have hydrogen bonds because they don't have hydrogen bonded to FO or N. Larger molecular alkanes, which generally have a carbon chain which are greater than 16, form waxy solids. As the number of carbons in your chain increases, so does the boiling point. So as you have an increase in molecular weight, the boiling point of the molecule also increases. So just something to know. The last property we'll look at, and you should probably already know this, is because they're nonpolar, they are immiscible with water, right? They do not mix with water. If we remember our rule from Chem 20, the rule is like dissolves like. So alkanes don't dissolve in water because water is polar, but they would dissolve in oil, for example, because oil is also nonpolar. So here are my IUPAC rules for alkane nomenclature. So this is more or less a step-by-step process you could follow to name a molecule. So we'll write down the steps and then we'll go look at them in an example. The first thing you need to do is find and name the longest continuous carbon chain. We call this the parent chain, and we would name it according to however many carbons it had with a ANE ending. So if I had, 6 carbons, it would be hexane. Once I have found the largest carbon chain, what I need to do is number the chain. And when I number this, I need to start at the end that has the closest attached groups. And we'll look at an example which will make this step a little bit clearer. Once I have numbered the chain at the closest attached group, then I would want to identify, name, and number the attached side chains. So if there was a 1 carbon side chain, I would name it a methyl. A 2 carbon side chain, an ethyl. So if there was, I'm just ignoring this, this would mean that on the 3rd carbon, there was a butyl, so a 3 carbon side chain attached. You may need to pause this if the kids are going to copy this down. Then the last step would be to assemble the name in listing the side groups in alphabetic order, placing prefixes if you have several groups of the same kind, and then the parent chain is placed last. And so here's an example, but it might not make sense. We'll go through all of these steps here when I look at an example.